Howdy! Today's exercise is Pac-Man. The goal is to learn some basics about Booleans and Boolean logic, a core data type you'll see in every application. We'll also get a bit more practice with a module and functions. We're going to use Google's AI Studio again as our trainer. And in the last episode, I mentioned using the turn coverage setting. I had thought it was about agent memory, but it's not. It's about the interaction patterns with Gemini. When it's turned off, Gemini only considers what's on the screen when speech is detected. And then once it forms a response, you can't interrupt it. But if you turn on turn coverage, there's a constant video and audio stream that should improve the overall experience. We're also going to switch to the Gemini 2.5 native audio dialogue model. It, in theory, provides a more natural conversation style. I recorded this exercise yesterday, and for technical reasons, I had to start over. But that's good news for you because Gemini 2.5 Flash was pretty intolerable with all of the underscores and now the inclusion of question marks. So we're going to see how the native audio dialogue handles these features. All right, so we'll fire up Google AI Studio. We'll go in on the left, we'll choose Stream. In the top right, we'll pick the native audio dialogue model. And we're going to choose Puck because that's the same voice we've heard before. I'll also turn on the turn coverage setting. Then we'll share our screen. Hi Gemini, I'd like you to be my teacher for the Pac-Man rules exercise in the Elixir track on exorcism.org. Can you help me?
Hello. Absolutely. I'd be happy to help you with the Pac-Man rules exercise. We can go through the requirements together and figure out the solutions. What's the first task you're working on?
This is the structure they've given me as a starting point to solve the 4 tasks involved.
Okay, I see the basic structure of the rules module with the function definitions. Let's focus on the first task, defining if Pac-Man can eat a ghost. According to the rules, when can Pac-Man eat a ghost?
It says here that the function should return true only if Pac-Man has a power pellet active and is touching a ghost.
Exactly. So the eat ghost function takes 2 Boolean arguments, power pellet active and touching ghost. It should return true if both of these are true. How would you express that logic in Elixir code? Think about the logical AND operator.
I can take that quite literally. Is this the function body you had in mind?
Yes, that's a perfect way to implement that logic in Elixir. The AND operator ensures that the function only returns true if both power pellet active and touching ghost are true, exactly as the requirements state. Now you can run the tests to see if this implementation passes the first task.
So while we're waiting for that, what's with all the question marks?
In Elixir, function names that end with a question mark are a convention for functions that return a Boolean value, either true or false. It's a way to clearly indicate that the function is asking a question and providing a yes or no answer. It makes the code more readable and clearly communicates the function's purpose.
And so the same is true for these arguments, that if it ends in a question mark, that's the convention to say this is a Boolean value?
Exactly. The question mark convention applies to function names as well as to variable names. It's a consistent style in Elixir to indicate that a variable or function return value is a Boolean. This helps make your code clearer and easier to understand for other developers.
Thank you. It appears that our task 1 has passed.
Great. It sounds like the eat ghost function is working correctly. That's a good start. Now you can move on to the next task.
All right, so task 2 is to define if Pac-Man scores, and it says the function should return true if Pac-Man is touching a power pellet or a dot.
Okay, so for task 2, you need to implement the score function. This function should return true if Pac-Man is touching a power pellet or a dot. You can use the OR operator to combine these two conditions. So the function should return true if touching power pellet is true, or if touching dot is true. Go ahead and add that logic to the score function.
I did, and I think it's right, so I'm going to start the tests.
Excellent. Let's see how the tests go this time. If it passes, you're one step closer to completing the exercise.
All right, task 2 is complete.
Great job! Now you're on to task 3, which is about defining the conditions for when Pac-Man loses. Take a look at the instructions and let me know if you need any help with that function.
So this function should return true if Pac-Man is touching a ghost and does not have a power pellet active.
Exactly. So you'll need to check if touching ghost is true and if power pellet active is false. You can use the AND operator to combine those two conditions. If both are true, the function should return true. Otherwise, it should return false.
So in the previous tasks, we were able to just refer to the argument value. But how do I compare power pellet active being false?
You can compare power pellet active to false using the equality operator, which is a double equal sign in Elixir. So you would write power pellet active equals false.
So like that?
Yes, that is the correct way to compare power pellet active to false in Elixir. That expression will return true if power pellet active is false, and false otherwise.
You know, I don't think that's quite what the exercise had in common because they're highlighting the keywords and, or, and not.
Ah, I see. In that case, you can use the not operator to check if power pellet active is false. You would write not power pellet active. This will return true if power pellet active is false.
So like that.
Yes, that is the correct way to use the not operator in Elixir. The expression touching a ghost and not power pellet active will return true if touching a ghost is true and power pellet active is false.
Very good. And the test for task 3 passes. So let's move on to task 4, win.
Okay, for task 4, you need to implement the win function. Pac-Man wins if he has eaten all the dots and is not touching a ghost, or if he is touching a ghost and the power pellet is active. You'll need to use the and or operators for this. How would you write the expression for that?
Well, the description says the function should return true if Pac-Man has eaten all the dots. So I think that's really straightforward, but has not lost based on the arguments defined in part 3. So this suggests it wants us to reuse the lose function.
Yes, that sounds like the right approach. You'll need to combine the condition of having eaten all the dots with the negation of the lose condition. So if Pac-Man has eaten all the dots and is not in a losing state, he wins. You can achieve this by using the and not operators in your function.
Okay, so I said has eaten all dots and not lose, and then provided the power pellet active and touching ghost arguments. Does that look right?
Yes, that sounds like the correct logic. You're checking if Pac-Man has eaten all the dots and is not in a losing state, based on the lose function. That should accurately determine if Pac-Man wins.
Very good, and all of the tests pass, so it appears we've completed the exercise.
Great job! It looks like the code correctly implements the win condition. You've successfully combined the conditions for Pac-Man to win.
Thank you, Gemini.
You're welcome. Glad I could help you verify the solution. Let me know if you need help with anything else.
I want to share feedback I got when I first submitted my answer to this exercise because you may see this yourself. If we go back to my iterations and go to my first iteration, my solution is exactly like you saw today. And I got this feedback that Tim Austin, another user, gave this feedback. Functions that are limited to one line can also be written in an alternate form. So rather than having a do, the content, and an end block, you can put comma, do, colon, and I'll show you that solution in a moment. But also, the Elixir analyzer says that this feedback is identical to one of their own implementations. So this is a perfectly good implementation. In iteration 2, I implemented some of the one-line functions, and so it looks like this. Eat ghost, comma, do, colon, and then the function body. And then you see there's no end to it. And I did that for the first 3. Perfectly good. I love this approach when the one-liner is short. I don't like it when it wraps. So I didn't do it for this last one. But you can also see that this solution is identical to their implementation and is perfectly fine. So either answer would have been perfectly fine. And it shows a first example of getting some feedback on a solution. I really liked the AI Studio with the native audio dialogue. It didn't stumble or sound awkward with underscores and question marks. It read those just fine. I think my opening request of it being a teacher was also very helpful. I think that set its role and its perspective better. I also think the turn coverage helped it keep up with what I was doing. For example, it didn't ask me to run the test when I've already run the tests, as I've seen in previous episodes. So we'll keep going with this native audio dialogue setting. We'll try out a few of the other features in our next episode. Thank you. See you again next time.